So good afternoon, one and all who are presenting over the online session for the wonderful session on third international conference on technological advancements in computational sciences organized by the Amity University of Tashkent along with the co-sponsorship from IEEE Kazakhstan subsection. We heartily welcome the session chairs who have magnanimously contributed their time for evaluating the various research articles from various research scholars. I am very glad to introduce the session chair of the session. Dr. Meghna Sarma, ma'am is along with us. She is a doctorate holder, is currently working as associate professor in the North Cap University of Gurugram, India. And her field of interest is in data science specialization. Madam has more than 20 years of teaching, research, and administrative experiences. Dr. Sharma has worked as a scientist in the control system group, and where, along with the ISRO Satellite Center, Bangalore, she was working. She is the recipient of award for science conferred by Government of Haryana. Her major areas of interest are machine learning, artificial intelligence, big data analytics, and data mining. She has more than 35 research papers to add to her crown as a very good scholastic researcher. And those papers were submitted in the international journals, conferences, book chapters. She has 3 international patents published and granted and 2 national patents published in the field of AI domain. And Madam has been an active participant in the program committees of several international conferences. And she is the reviewer in various editorial boards of eminent reputed journals, international journals. She has many certification courses on cutting edge technologies in the domain of data science. And to add colors to her feathers, she is acting as the NPTEL in charge, Coursera in charge for various national universities, representing various national universities. She has obtained her doctorate of philosophy in the area of machine learning from IC Bose University of Science and Technology, YMCA, India. Ma'am, we welcome you wholeheartedly for this wonderful session, and participants are eagerly waiting to hear your comments upon the evaluations on their various research articles. Thank you so much for accepting our invitation. Thank you for being with us for this time. Thanks a lot, ma'am.
So
and the session track allocated for us. Yeah, thank you, ma'am. And this track session title is named as Emerging Techniques in Machine Learning, Applications in Health, Agriculture, and Finance. So papers will be from these arenas, ma'am. And coming back to our another session chair, who is Dr. Satyabrata Roy. Sir is working as Associate Professor in the Department of Computer Science and Engineering, School of Computing and Information Technology at Manipal University, Jaipur, India. He received his PhD and MTech with honors in the field of computer science and engineering in 2020 as well as 2014 respectively. And he did his BTech in information technology in the year 2009. His research interests include cryptography, Internet of Things, cellular automata, computer networks, computational intelligence, machine learning, and formal languages. He is an enthusiastic and motivating technocrat with more than 10 years of research and academic experience at different reputed institutes. He has supervised many students for their MTech dissertations work and currently supervising PhD scholars of Manipal University, Jaipur. He has published many research articles in top quality international journals, national and international conferences with higher reputations. He is also working as reviewer for several reputed international journals He has served as a member of Technical Program Committee of many international conferences and symposiums. Sir has organized many international conferences, FDPs, and workshops. He has participated in many short-term courses, faculty development programs, workshops, and MOOCs offered by prestigious universities of India and abroad. He has served as a resource person of many FDPs and seminars. And one another great thing is he is the senior member of IEEE and he is the professional member of ACM. Warm welcome to you, sir. Your presence makes us this function very more successful. Thanks for your support, kind support. And the session title, as I mentioned earlier, sir, Emerging Techniques in Machine Learning, Applications in Health and Agriculture and Finance. So papers will be selected in this manner. Totally, we have 11 papers for this session, sir. So the evaluation sheet I will share with you shortly. Meanwhile, shall I give the forum to the participants to present their papers, session chairs?
Yes, ma'am. Thank you for the introduction, and I'm fortunate to chair the session with Dr. Meghna Sharma, and I thank Amity University Tashkent also. Yes, we can, ma'am, we can share this forum with the participants, I think.
Yes, thanks a lot, sir.
Okay.
So participants, now the forum is yours. So participant with paper ID 49, a novel approach for predicting stock prices, infusion of investor sentiment and stock data. Are you available here?
Yes, ma'am. Yes, ma'am. Available.
Yes, sir. Yes. Forum is yours, sir. You can present, sir. Next participant paper identified CNN SVM strategy for taro leaf blight disease. Okay. So, sir, participants, your timing will be 10 minutes, of which 8 minutes is for presentation and 2 minutes is for your question answer discussion session. Over to you, sir.
All right. I hope my this screen is visible to you.
Visible, sir. Visible.
Yes, it's visible.
Visible, sir.
Thank you.
Yes,
Thank you.
visible.
Thank you, sir.
Put your camera also on.
Yes. So this is
Paper ID is 49, sir.
Paper ID is 49. Okay, that's good.
I will share the evaluation sheet quickly.
Okay, okay, no issue, no issue.
Okay. So very good afternoon to one and all present here. This is Harmanjeet Singh, and my research article is Novel Approach for Predict the Stock Price Infusion of Investor Sentiments and Stock.
Harmanjeet Singh ji, may I request you to please put on your camera?
Oh, okay. Yes, I hope now.
Yeah, you are visible.
Yeah.
Thank you.
Thank you. Okay. So my research article is a novel approach for predict the stock price in fusion of investor sentiments and stock data. And this is the content I'm going to cover in this presentation. So first I start with my abstract. So as you all know, the stock market is intricate and a non-linear, rendering it susceptible to unpredictable events and outcome because of its a non-linearity data. So this study, which I with my co-author, shows that a well-tuned artificial deep neural network model can be used to deal with a time series event that do not follow a straight line, like changes in a stock market that we all know. In this study, we introduce a model which is fused with the historical data of a stock along with the sentiment analysis of that stock. So we choose a Reliance Industry to predict its stock market, predict its stock price in future, in fusion with the what news has going to be published for Reliance Industry in a financial or economical times. So in this, we used machine learning for sentiment analysis and a deep learning for the predicting what could be the forecast price in future for a Reliance Industry. And we come to the conclusion of our model that is a bidirectional bidirectional gator recurrent unit got highest accuracy in this. So let's start with first introduction part. So as you all know, due to recent technology, stock market is because of non-linearity. Everyone is going to be invest in a stock market, but the risk is there, right? And to anticipate the potential outcomes, to get a more profit from this kind of domain, which has a higher risk, and so to overcome the risk for the investor, we actually make a model on which we used a fusion of a sentiment analysis. So literature survey, in this paper, the authors used a LSTM model with the Twitter data. Although Twitter data is a very unofficial data, it's not authentic one for a sentiment analysis, but yes, they used it, and the data they took is from 2009 to 2020. It is 11 years of data they have used, and the error percentage rate was 1%. Although what actually the challenge they have faced is they didn't mention the direction of the stock price, whether it will be go up or down. So if it is go up, how much will be go up, and if it is down, how much it will be go down. So that was the part which is they faced during their this research. In second article, in second research paper, the authors again use LSTM neural network, because at that time, because it was published back in 2019 or 20, so LSTM was the main machine deep learning model or a neural network which was rigorously used for this kind of time series data. But now with the invention of a bidirectional gated recurrent unit, we used it, and we got two things from this. The first one is the direction, in which direction our stock price will be go, and at what extent it will be go up or down. And yes, in the latest one, in this research article, the authors used a Taiwan stock market stock data for some stock securities, and they use this GA again LSTM, and the latest accuracy they have predict for a sentiment analysis was 58.89. This was the data, this was the accuracy for a sentiment analysis. Okay, what we proposed in our model is we actually fused the stock historical data as well as the news published corresponding to a particular stock. Let's say we use a Reliance Industry for this whole research article, because Reliance Industry has a long establishment in Sensex, BSE or NSE. So we used the data of this Reliance Industry. We obtained data from NSE website from 2018 to 2020, last 5 years of data. Why it was last 5 years data? Because BJP came into Indian government in 2019, sorry, the second term. And the Reliance Industry is established corporate so that we can predict its the stock price. So both the things are in favor to us. So that's why we choose the Reliance Industry. So in this model, what we used is we use a National Stock Exchange for historical data, and it has 6 indicators: open price, close price, highest price, low price, adjusted close price, and volume. Volume means how many stock has been traded in a single day. Okay, and then we used a augmented Dickey Fuller test to make a stationary data, because as we all know, time series data is a very fluctuate, very dynamic in nature, and so we can't predict in that case. We need to make it stationary. For that purpose, we use a Dickey Fuller test. And after that, we generated the technical indicators like a moving average, 1-day moving average, 2-day moving average. So these are technical indicators we used to find out the insight from that data. And after exploratory data analysis, and this is the one part. And another part is, below this fusion is a economical times data source. Actually, this is a financial newspaper. From this, we web crawl the news which were published about Reliance Industry in their newspaper. So using this stemming, lemmatization, TF-IDF, BERT, everything we used it, and then we got a second data. So first data set is for historical data, second data set is for a news data, and then we fuse it. The fusion on the basis of date. On what date the stock prices goes and up, and the same date what was the news which was published in Economic Times. So we fused both the data set using a date, and then we apply some machine learning and deep learning model. So in machine learning model, we come to know either this price go up or down. After we come to the conclusion, okay, if price goes up, then we apply a deep learning model, that is the BGRU. bidirectional gated recurrent unit. Why we use it? Because in that it has a capability to look at the 100 days back of data. Like in LSTM, we can track the next day data, next day predictable data on the basis of what was the trend from the last 100 days or 200 days. So that is the capacity that we have in our gated recurrent unit. And for sentiment analysis, we use a valuation parameter like accuracy, precision, recall, and score. And for stock price, we used a stats valuation parameter like MSC R2 scale. So in experiment study, this is the data that we got it from my National Stock Exchange about Reliance Industry from 2019 to 2023. As we all said, okay, why it was 2019? Because BJP came into power and the Reliance Industry was is a established one. So we can predict its stock price in the future. And after go through the Dickey-Fuller test, we extract the technical indicator. The major one is the ADX and RSI. So ADX value, which is above 50, indicate it's a high trend. So we observe the multiple events RSI. If it is beyond 70, so consider to be overbought, because it might be happen because some bogus news has been published in economic. That is a very rare chance in economic times. And so if it is a bogus news and still your stock is going again in a increasing trend, so it's overbought. Same we consider if it is oversold on if RSI is equal to 30. For sentiment analysis, this is the whole scenario for sentiment analysis. We use pandas to web scrape Reliance Industry stock from Economic Times on the basis of company name, date published, author, headline, description, article bodies. So these are the parameters which we use during a web scraping. And we use the beautiful soup to parse the data into HTML. Then we use text pre-processing like a stop, stemming word, lemmatization. We all use all data pre-processing for text data. Later on, we use a weather, which gives on the basis of the rating score of a compound score from a weather. So we declare if it is above 0.6, so we are considering the news is a positive news. And if it is below 0.5, then it will be a negative. So if it is between 0.5 to 0.54, then it would be a neutral. And what it impact on a stock price, that we have changed, that we have to check to the sentiment analysis. Yes, these are the things which we just have told you in our previous slide. This is like we check the punctuation. We used we convert upper letter to lower letter if it is any upper text in our news. Degree modifier, conjunction, then weather, then the polarity negation. And this is the last, overall data that we had after combining our historical data and sentiment analysis. Accordingly, we combine with the label. So if it is label 0, that means the stock is going to be in a downward direction, in a downtrend. If it is a 1, then it should be go in a upward direction. How it comes? It comes from the historical data and the sentiment analysis with the weather. And when we apply our modern machine learning model to predict how much accuracy, so we got around 0.7 decision tree, which gives us a 0.7 accuracy. Although we used another model also, the best one we got accuracy in a decision tree. And same, then if it is decision tree, then we apply deep learning model, that is a gated recurrent unit, to check how much it will be good to predict the price. So it gives us 4.7 RMSE, which is quite better than the earlier model which was developed by other such authors. And so this is what we have achieved till now. So in future, yes, this is a graphical representation of. So what we did is on April 3, 2023, the actual share price of a stock was 2331.45, which was near to the predicted price of a 2309. So this is okay if investor have a good idea of what could be done in a future if it is he is investing in a Reliance Industry. So our model is able to give a true picture. So how it will we behave in a future according to the price or according to the direction. About future enhancement, yes, we can have another source of data from text, like we use only Economic Times. We can have it a moneycontrol.com. We can have other sources of data set to extract the news. And because historical data will be remain same, either we will change the source also, that doesn't make any sense. But yes, for news that we can explore the more sources. And second, we only choose a Reliance industry. We can have another established corporate also. We can apply this model to those corporates and check whether our model is going to be give a same accuracy or a more accuracy, what could be the done. So that's from my side, and these are the references. Yes. So that's all from my side. If you have any question, please ask.
Okay, Harmanjeet Singh ji, can you tell me, is there any specific reason that you have taken bidirectional GRU? And I mean, did you try to compare it with bidirectional LSTM also? Or
yes, ma'am.
basic LSTM?
Yes. Actually, in basic LSTM, we can't predict what could be the future outcome of a stock, because in normal LSTM, it will only keep a track of the previous days. It will not go into upward direction. I mean, in a coming direction. Say if I'm choosing today, what could be the today price? So in this normal LSTM, it will give us me a today price on the basis of the last 100 days of that stock. So it will not go what could be the tomorrow price, or a 1 week after price, or 1 month after price. So for that purpose, we use a bidirectional.
No, that's fine. Bidirectional GRU you have used, right? I'm asking
yes.
bidirectional. You have not shown anything about bidirectional LSTM, I think.
LSTM, yes. The basic challenge with the LSTM is, which I have, in my opinion, LSTM will not go beyond, 10 or 20 days, because we used 100 days of data, previous data. So GRU has that much of caliber to predict the tomorrow price, keeping a track of the last 100 days or 200 days also. Because we have we have a huge data of 5 years. Even some articles, they have used 10 years of data or 15 years of data. So in that case, LSTM, I think it was not feasible to predict the next day data on the basis of last 10 days data or last 20 days data. So that's why we use the GRU.
Based on the theoretical assumption, you have not done, you have not tried it, okay, right?
Yes.
Okay.
Harmanjeet Singh ji, good afternoon.
Very good afternoon, sir.
So may I know what is the data source of the data?
We use two data sets. For stock data, we use NSE, National Stock Exchange, India. And for this text data, news data, we use Economic Times.
Okay, can you go back to that slide?
Yes, sir.
Data sources are there.
Proposed model, right? This one.
Yes. Have you mentioned here any link?
Link, I have just mentioned the domain name, economicstime.com.
Okay. Then you have mentioned in slide number 5 that there is some error percentage. So how that error percentage have been calculated?
This error percentage.
Yes.
This was the article by some other author. Actually, they used Twitter.
It's which type of error you are mentioning? You are referring?
Error detection they have mentioned in their test data. I mean, the model which was good might be good in a training model, but it's not that much good in a test data set. So that was the 1% of a fluctuation in a training data set as well as test data set they have mentioned.
Okay. And you have also calculated some mean squared error and mean absolute error, I think. What was the necessity of that?
Root mean square error.
No. In the last slide, you have mentioned means additionally you have computed MSC and MAE values also. So what was those values?
Mean absolute error value.
Yes.
This is a slide.
Towards last slide, just
this one.
No. Next. This is RMSC. Then go to next slide. Next.
Future enhancement.
In this slide. Yes. Have you calculated these things? Just second last point.
No, I think RMSC. This is a type error. RMSC, R2, and MAE.
Not calculated MSc,
Yes,
MAE.
yes, yes, yes. This is a type error.
Okay. It's from my side.
Yes, RMSC, R2, and yes, these are two. The
So
type.
MA value you haven't calculated.
No.
Okay. But you have mentioned, no? That is
Yes,
why I
it was a type
asked
error.
you.
Sorry from my side.
Okay. No problem.
Thank you, sir. Thank you for your nice presentation.
Thank you.
And this is information to all the participants. Once the presentation is over, please remain in the link so that we will share with you the feedback form. So once the feedback form is filled, you are requested to leave the meeting. And meanwhile, the presentation will be evaluated on these rubrics. Totally 10 points will be awarded for each presentation, out of which the rubrics goes like this. Technical contribution will carry 4 points, and methodology which you applied will carry 2 points, and discussion on your results and analysis will be evaluated for 2 points. Then presentation will be evaluated for 2 points, totally 10 points. And in the third day of the conference, there will be valedictory session, and in that session, best 3 papers will be announced. So the scores will be consolidated from the session chairs, and accordingly your marks will be evaluated, and based on that the best 3 papers will be selected and they will be awarded during the valedictory session. So I request all the participants to stay in the session throughout the session. And next participant is 63, Ankita. So Neeru Bala Bharatwaj, Dr. Neeru Bala Bharatwaj is available here. 90, paper ID 90. Identify brain stroke in severity and symptoms in sex difference using AI ML. Authors, please kindly respond.
I think it is absent. He is absent.
Yes, sir. 63 asked permission, sir, right now. They stated that they are on
Okay.
travel. So,
Okay.
author ID, paper ID 150, authentication of voter using convolutional neural networks and blockchain. Shall we go like whoever is available accordingly? Shall we go like that?
Yes, we can
We
go.
can do that.
We can do that.
Yes, ma'am. Whoever is ready, may I know that? Shruti Batla.
So Priyamada is saying she is ready. Dr. Priyamada.
Yes, ma'am. You can carry on, ma'am. Dr. Priyamada, ma'am, please carry on. Priyamada, ma'am, paper ID is. 1 minute, ma'am.
In the chat, she has written. I'm ready. Paper ID 246.
Okay. Yes, 246.
246.
Yes.
Good afternoon, respected session chair, Dr. Meghna Sharma, madam. Is it visible,
Hello,
madam?
ma'am. Yes, your PPT is
Yes,
visible.
it is visible. You can continue.
You are not visible, your PPT is visible.
Yes, madam.
Yeah.
Am I visible, madam? Now?
No, ma'am, you're not visible.
Some technical problem is there. I think some net issue is here.
Not a problem, ma'am. You can continue.
Yeah. So
Just
good
make
afternoon,
it a full
Dr.
screen. Make it full screen.
Full screen. Yes.
Is it full
Presentation
screen?
mode, ma'am.
No,
Yeah,
not full screen.
Make it as a presentation mode.
Yeah, I have done here. Here it is showing presentation mode.
You can just refresh it or you can join again because it's not in the full screen mode. Yeah.
It is stuck. We cannot see the full screen presentation.
Just a minute, ma'am.
No,
Can you
it's not.
can you just change the PPT so that we can see if even if it is changing, you can just
Yes,
change
yes,
it.
that is also.
Yeah, right now it's
Now is it visible, madam?
it's visible. It was visible earlier also, but still it is not in the full screen
Visible.
mode.
No, I have done in full
Okay,
screen.
you can you change the second slide to the second slide, because we can see the first one only.
Yes, yes, we can see the first one. You press arrow key.
Yeah.
Press arrow key. Arrow.
Arrow.
Yes, yes. Just go to the next slide.
Yeah,
yes.
you're not. Yes,
You can
I
start.
think.
Is it okay, ma'am? Now?
Yeah, yes, it's fine.
Yeah.
We can. Yeah, you can keep on changing like this. Yeah.
Yeah. Sure, ma'am. So, good afternoon, Dr. Meghna Sharma, ma'am, Session Chair, Dr. Satyabrata Roy, sir, Session Chair, Dr. Gayatri Devi, madam. So, the topic of my presentation is solar radiation prediction based on hybrid machine learning techniques. So, here in this work, I have predicted the amount of solar radiation which is coming from sun to earth, so that we can predict the amount of solar power generation, so that we can use that prediction for better use of renewable energy when we connect it with the smart grid. So the content will be having abstract, introduction, existing system, literature survey, proposed architecture, result discussion, future enhancements, and references. So solar radiation forecasting is crucial for optimizing solar power generation systems and integrating solar energy into the energy grid. So traditional physical models which are available right now, they are having limitations in prediction accuracy. SCADA systems, in most of the places, SCADA system is used for prediction of the solar power generation, and taking the various other parameters like wind energy, solar radiation amount, and pressure, humidity. All these are taken from meteorological stations. So these are having some limitations because the accuracy of their prediction and the speed of their prediction is very slow. So they are also having the complexity of atmospheric processes. So this research presents a novel hybrid machine learning approach that combines random forest and XGBoost algorithms for solar radiation prediction. The proposed hybrid model leverages the strength of both the algorithms to enhance prediction accuracy. The simulation results demonstrate the superior performance of the hybrid model compared to the conventional models, offering a promising solution for efficient solar energy utilization for a greener future. So in the introduction, solar radiation forecasting is crucial for optimizing solar power generation system, as I told earlier, and integrating solar energy into the energy grid. So radiation from the sun results in production of heat. It can set off chemical process in the solar cells, and it can even be used to generate electricity. Therefore, in order to construct and properly equip solar system, it is necessary to calculate the quantity of solar radiation that is present throughout the various periods of the day. So here, the amount of radiation varies with the different time zone of the day, as well as the different seasons in the year. So we can predict all these in all these scenarios what will be the amount of the solar radiation with the help of machine learning technology. So solar radiation prediction has traditionally relied on physical models based on meteorological data and environmental variables. To improve the accuracy of solar radiation prediction, machine learning techniques have emerged as powerful tools. Machine learning leverages the analysis of historical data to identify patterns and make data-driven predictions, offering a promising avenue for enhancing solar radiation forecasting. This research offers a solar radiation prediction based on hybrid machine learning technique. So the existing system, when we talk about the existing system, prediction system for solar radiation, these are the models based on various work has been going on in the existing system also on machine learning, and they have used the different models based on machine and deep learning techniques. So researchers have applied various machine learning algorithms like random forest, support vector machines, gradient boosting for solar radiation prediction. Deep learning techniques models have been employed for solar radiation prediction, but these models are more complex, time consuming, and less accurate. So I have surveyed approximately 25 to 30 literature papers for this work. And the main papers which I have referred are the first one is this written by QT Fan ETL, who has present deep learning method to improve the performance of short-term on 1 hour ahead solar power forecasting with 90.70% accuracy. Mr. M. Golam, ETL, presents LSTM technique and optimize MAE, MSC, and root mean square error of SIPNet, and which is he got the results 0.413, 0.33, and 0.57 respectively. ZWoo ETL presented a novel multi-scale MTS prediction framework to fulfill the multitask application and eco-state network in the proposed MTS framework. ZMETL, hello?
You can continue.
Okay, sir. ZMETL presented artificial neural network, ANN, to investigate the impacts of direct solar irradiance and wind speed on the heat demand from the perspective of the entire district heating network. So these are some important previous works which has been done with the use of machine learning technologies to predict the solar radiation prediction for better accuracy. I have proposed this work by using hybrid machine learning technologies, in which I have used the qualities of best hybrid machine learning techniques. One is the random forest technique, and the second one is the XGBoost technique. So by combining these two methodologies, I have used these two technologies I have used for classification with my data. So first I have collected solar radiation data set, then pre-processed, then feature selection and trend test split I have done. Then I applied the hybrid model, which has the combination of random forest and XGBoost, and then I analyzed the performance of the model. So the data I have collected for solar radiation, along with the meteorological data from this publicly available data site, www.kaggle.com. And then I applied pre-processing step on that data where I handled the missing data and null values of data set. Then feature selection process has been applied to perform, followed by the data splitting. The hybrid random forest and XGBoost machine learning clarification method is then applied on the tested on the data. Then using the testing data set, an analysis of the performance of the hybrid model is carried out. So the parameters I have calculated for getting the accuracy of the prepared model are root mean squared error, mean squared error, mean absolute error, and other similar matrices which has been calculated in the context of regression task. The Python Spider IDE is used for the simulation of the work. So this is the data set of the solar radiation along with the other meteorological parameters like humidity, temperature, pressure, radiation, time of the day, sunrise time, sunset time. All this data I have collected from Kaggle side. And this data is having, which I have used, having 32,686 rows and 11 columns. So this is the result, the graphical representation of my result, which I obtained by my calculation with the hybrid machine learning technique. So here the blue line is showing the observed solar radiation, and the red line is showing the predicted solar radiation. So you can see that the predicted value and blue line, the observed value, are very near. It means my methodology is giving me approximately accurate results for prediction. So these are the parameters I have calculated from my data set, from my hybrid model. So MSc I got 0.30, RMSc I got 0.45, and R squared I got 0.93. So when I compared my results with the existing methodology, which I mentioned on my literature survey on number 1, I have where they have used the convolutional long short-term memory technology for this prediction. So as compared to the existing methodology, I got better results. Like MSc, I got 0.3, RMSc, I got 0.45, and R squared, I got 0.93 in place of 0.70, which the existing method got. So where we can implement this technology, if we talk about the implementation of this model, there are various places in India as well as across the world where solar power is used. As India is going to be third largest renewable energy source country, so we can use this model, developed model for a better prediction of the solar radiation, so that we can better use our existing smart grid system, and we can better regulate the power supply from the renewable energy to the smart grid. And also the future enhancement which I can do in this present model, I can implement some more combination or hybrid technique using machine and deep learning, and I can take other data sets also from other sites, because India is having so much large landscape with different geographical situations. So from other sites also I can take the data and then use this model to implement and to predict the radiation of the solar power. And then I can find and calculate some more parameters along with the radiation, some more parameters like solar power generation and other parameters also. Or we can combine this along with the solar power, we can combine the wind power stations, biogas stations data also, and in this model, and we can predict the values of those parameters also by using this model. And I can test present model with real-time scenario, because Government of India, this Ministry of Power has settled 11 renewable energy management centers throughout the India. So where there we can install this developed model, where it can be helpful for prediction of renewable energy generation, for which will be further useful for better regulation of the smart grid. So these are the references which I have used for this work. So this is all from my side. Thank you very much.
Okay, Priyambada. Dr. Priyambada, I just want to ask first one thing. The literature survey, what you have done, and the data used in those survey, is it the same data which you have taken, or like some different data set?
Ma'am, I have directly taken data from Kaggle data site. So that data.
Your voice is not audible, ma'am.
Hello.
No, it's audible for me. Like I can
Hello.
hear. Yes, you are audible. You are audible. Please continue.
Yes, ma'am. So, ma'am, the data I have taken from Kaggle side is just matching with the data which is being used for this
existing method
prediction technology. Yeah, it is just matching, ma'am.
Okay. So I mean, see, you have taken random forest, the hybrid of random forest as well as XGBoost. So both are like, I think these methods, they are using multiple models. So isn't it
Yes.
like, I mean, how did you manage this training time? Because as far as the technicality is concerned, both of them will be, they are ensemble methods. So, I mean, how did you manage this hybrid? The combination will be all the more, time taking. So, so how did you, manage this training time? Because how long it took to train the model with your data?
Ma'am.
You're on mute.
Hello.
Yes, you're audible now.
Yeah. Yes, ma'am. So, ma'am, I reduce the time by giving all the parameters together in blocks, so that this combination can get the reduction in time, ma'am.
But that's the basic idea behind ensemble method. You actually create the batches and then you give the data to the different models and then you combine the results, right? One is sequential, one is parallel. So
Yes.
how they had these two combination gave you the advantage? I mean, how can you explain that?
Ma'am, I use the this qualities of XGBoost method, so that this is very useful for this classification, and this give the very accurate result, which this is very famous for this part. So this was very useful after this giving data to this random forest. Then I just applied this XGBoost, and the final result I got was very accurate, and less time I took.
Okay, my last question. I mean, how did you do feature selection? You have mentioned in your processing part that
Ma'am,
you
features along with the value of the solar radiation, I took the features like wind velocity and pressure, humidity, and
so you have
angle.
done it manually, or did you apply some methods of feature selection?
Ma'am, I did it manually, ma'am.
Okay. So probably you might have taken some other set of features and the result would have been different in that
Yes,
case.
sir. I combinedly give all the features to the model, and then it has been selected, ma'am.
Okay, that's all from my side.
Thank you, ma'am.
Okay, Dr. Priyamada, can you go to slide number 3?
This one, sir?
Yes. So in the second point, you have mentioned that traditional physical models have limitations in prediction accuracy due to the complexity of atmospheric processes. Do you have any references for that? And how can you say that limitations are there, or which type of limitations? Can you show us that particular survey?
Sir, this is available on the renewable
supporting data. What is the supporting data against your this point number 2? Which type of limitations are there?
So limitations are mainly, sir, when they sense the these values of the means
I can understand, but it is you cannot write it on your own. You have to support your statement with some literature review or some pre-published data, because we
sir,
are all.
I have many talks with the regulatory persons who are sitting at the renewable energy management centers of India, and they used to tell us that they are unable to predict properly because of all these complexities they are facing. So they badly need the this artificial intelligence and machine learning technology model for that accurate prediction. So on the basis of their statements, I claim that these are the limitations of the present methods they are using.
In my opinion, it would be very great if you just participate in some panel discussion, but when you are writing something in some written form or you are publishing something, then your statement must be supported by some data. This is a generalized opinion. However,
sir, they are using SCADA system. They are using SCADA system at their facilities, and they are using the sensors for balloon sensors. They are using for getting the atmospheric data, and then they process that data, and various times that data is not proper, so that it will take more time to get the results of prediction from by using those data and those facilities which they are having.
Okay. Now go back to that literature survey. I think 5th or 6th slide.
Which one, sir?
Next. Go to next. In literature survey, literature review.
Next one, literature survey. There's a PPT there.
In the PPT literature survey you have written, not references, literature review.
This one, yes, this one.
Yes, sir.
Yes. Now, you have mentioned here like you are presenting something, and you have mentioned here like 6th reference, 11th reference. So, what are those references? Can you show us? Show us the reference number 15.
So this is the first reference, and M. Golem, sir. This is the 6th reference.
So my point is that that you should, if you are using some numbered value, numeric value, you should list the references in that manner. Otherwise, you
Yes, sir.
can
Yes, sir.
give a footnote
Yes, sir.
of
Yes, sir.
you could have done it.
Yes, sir. Yes, sir. So this I have done in my paper, sir.
I can
In my
understand, but
paper.
you are presenting something, and there you are writing these type of things. Now, so here also you have to show
Okay,
like
okay.
this. Otherwise, you could have
Yes.
used that footnote type of references thing.
Yeah.
Now, can you
I will
come to
change, sir.
that?
I will change. Yes, sir.
Okay. Can you come to that table where you have shown us the values of RMSC, MSC?
Yes, sir.
What does this RMSC and MSC calculate? And what is the necessity of using these two parameters, these two matrices altogether?
Yes, sir. So these are the parameters. These are the by using these parameters, we just cross verify the performance of the developed model.
Correct. What are the other parameters, other metrics available to find out the errors? Why didn't you have calculated those like MAE? MAE is also there, or some other parameters. Do you know?
No, sir.
Apart
I
from
just
MSC and
calculated.
RMSC?
I just forced this means I just preferred for the calculation of these parameters, these main parameters.
But I
Is
think
any
mean square
reason
error
behind?
and mean square error, they are the repetition only. I mean, you can.
Yeah, that is why I was asking that you are calculating MSC and again you are calculating RMSC. Is there any compulsion, or is there any logic behind that, or you are just doing because all the other papers are showing like this?
Yes, sir. I just wanted to compare my results with the other existing models. That's why, sir, I use these parameters.
Okay, you didn't get my question. Anyway, I'd like to stop here. Thank you.
Thank you, sir.
Thank you, Dr. Premada. Next participant is 315, paper ID 315, Professor Bandari. The topic is an ensemble regression model to predict the rent of a house.
Can you see my screen? Can you see my screen?
Yes,
Yes, your
screen is visible.
presentation
You
is
are audible.
visible.
Yeah.
Can present.
This is visible in presentation mode.
Yeah, it's visible.
Visible?
It is.
Okay.
Yes, it's visible.
Yeah, you can go ahead.
Okay. Okay. I am Rahul Bhandari from Chandigarh University. I am present my paper, which is based on the SML regression model to predict the rent of a house, because you are going to outside the state or outside the country and etc, and you have know about the area and the locations. You only know about the locations, do not know about the area, where it is mall and where it is a shopping mall, and you have applied that, you view about the rent, and this that's why we have write this paper. Okay, and this is my content, that is on abstract, introductions, and existing systems, and literature survey, proposed architectures, and the result, and discussions, future enhancement, and references which are used in this paper to write this paper. First of all, abstract. We already told that what is the today's era, that is there is a property, there is a real estate, accessing property value has an essential essential for the multiple sectors, including the real estates, taxation, economy, and the stock market. The price of the house rent is closely intertwined with factors such as the population, geographical locations, and necessity for the additional data for accurate individual price predictions. Because some of the property dealers tell the high price when you are do not know about the area, and in these situations we have not predict the something predict some correct prices. So the current is study focus on the application of the assemble algorithms for the predicting the real estates and the house prices. And this algorithm comprises different regressions models, that is the bagging regressions, histogram, boosting, stacking, and rigid regressions to evaluate the predictions prediction accuracies. And this research is examine the root mean squares and root mean square errors to score the training models, and we achieve this accuracy that is 83.74. Okay, and I will use the data set from the Kaggle, and then I will in future I will apply on my app. And this is a existing system introduction. Already told that in this modern area, making the decision is the purchase the some home or and you are going to outside, then we have to
You can skip this part. You can come to your
Sure.
problem, like what have methodology you have
Okay.
used. That's it. Yeah.
Yes, yes.
Okay. Okay, this is a literature survey I will done with various papers.
No,
Some
come
of
to your
papers I will
proposed
be
model.
that is a reference one, which is
Rahul,
okay,
can
only
you,
only
yes,
proposed
can
model.
you
This is a
just
proposed
come to your,
architecture. Yeah. Uh, this is a proposed architecture. Okay, and the data set will be come urgent from the Kaggles, and these are the tables. These are features of these data sets. Okay, and these are the left hand side, right hand side. We have the proposed architecture. First of all, we have import the library in the Python, then the importing the data set which is downloaded from the Kaggle, and this data set is a raw data set, so we have handling the data with uh, check there is no blank space or the blank data is there, and all the pre-processing are done. Then we split the data into the training data set and the testing data set, and then future scaling is there, and then we have applied this regressions model on it and find the predictions. And after we have apply this model in this before the setting the parameters, we have the accuracy of the 14% in the linear regression, random forest, and gradient boosting, extreme gradient boostings, and this is shown in the table number 2. And the table number 3, when we hyperparameter is setting the some values from that, and we get that the stacking regressions, and these are the values which are set in the for the histo gradient boosting regressions. And the table number 5 will shows the value which is set for the rigid regressions. And for the hyperparameter we set for the bagging regressions, and these are the after we setting all the values, then we have find that the bagging regressions will be a more accurate from the other regressions models. Okay, and the less error will be there. The 90% error will be there, and these are the result from my model. And these are the conclusion. We already told that I will apply the machine learning algorithms for predicting the price of the house rent or the price of the house of the locality, and these parameters will be set of the regressions that is the bagging, stacking, histogram, boostings, and the reset. And I will achieve that achieve accuracy that is 83.74 from the bagging regression, and with low error, that is only a 11 to 14% error. Okay. These are my conclusion, and these are the future enhancement. Other models will be apply on that, and we have tell that which model will be accurately work for this data set or other data sets, and these are the references which are used to make this paper. Okay, thank you. Any questions regarding this?
Okay, Rahul, first tell me the accuracy you're talking about. What is this? Training accuracy or test accuracy?
So I will tell. Yeah, this is accuracy will be achieved for the testing accuracy, not a training accuracy. Yeah, 83%.
Okay. So what was your split of training and test data?
That is 75 and 25. 75 for the testing and 25 for the sorry, 75 for training and 25 for testing.
So you didn't mention all these hyperparameters and these values in your paper. Did you do some hyperparameter tuning also? Because you have mentioned many hyperparameters you have fixed on your own, or like you have done some hyperparameter tuning.
No. Yeah. I will done the hyperparameter tuning for the regressions. I also done
hyperparameter tuning method have you applied?
Yeah, applied to in the Python. From the Python.
No, I mean which method? There are different methods of hyperparameter tuning. Which one have you taken?
Didn't know.
So how can you fine tune that? How can you apply those methods if you don't know the name even?
No, I will just apply the functions on that.
No, I mean there are some available functions.
Yeah,
of course there are functions. That's what we are asking. Which functions you have used?
Something I didn't know that exactly. I not know that, but it I will apply on that is so, ma'am, I did not know about this. I skipped that thing.
Okay, are you aware about this algorithms which you have implemented? Are you aware what is this bagging, boosting?
Yeah, something is applied. Yes, sir. Yes, ma'am.
What have you done? I mean, what do you mean by bag? Can you differentiate between bagging and boosting?
Bagging and boosting.
You have used bagging, right? Bagging regression, you are saying.
Yeah.
So what is bagging? What is bagging?
Ma'am. Yeah. Ma'am, bagging is that is a assemble technology, which is fits for base regressions, such as we take the randomly data sets. Randomly data from the data set, and we can aggregate the individual regressions and then combine that regressions value and get the result.
Merging of the also it is a merging of the same type of
same data type. Yeah,
it's same data type you are saying. Okay, fine, Rahul. Done from us.
Yeah.
Okay, Rahul, I'd rather say that this is a very poor way of presentation of your paper. Maybe your co-authors are aware about what you have proposed in greater details. It would have been great if they would present that. because presentation style is not that much good. I would say that's all from my side.
Sorry, sir, for that. Sorry. Okay.
Because you cannot see any comparison, you cannot just justify your answers, what you have presented in the presentation and all these things. This is a not actually a good way of presenting in some international level conference. You should be well prepared before presenting all these things.
Okay, sir.
Anyway.
Sir, thank you. Okay, sir. Thank you, sir. Sir, sorry, sir, for that.
Okay, let's move on.
Thank you, Professor Rahul. And next is Professor Anuj. Are you there, Professor Anuj?
What's the paper ID?
Paper ID is 317, Efficient Disease Detection in Wheat Corns, a hybrid deep learning solution.
Okay.
Yes, over to you, Anuj.
Am I audible, ma'am?
Yes, you are audible.
Okay. Okay. Hello, everyone. My name is Anuj Jain, and I'm gonna present my research paper on efficient disease detection in wheat crop. This is a hybrid deep learning solution.
Pardon, what is your paper ID?
370.
370. Okay.
317.
Okay. Please go ahead.
So this is the content that is abstract introduction, existing system, literature survey, proposed
Yes,
architecture
Anuj,
result.
you can come to your problem and you can define.
So the abstract is where wheat rust disease poses a significant danger in global food security, right? And the required rapid and precise diagnosis to be effectively managed. We are using actually a hybrid deep learning model consisting CNN, that is conventional neural network, and decision reading. A new method of classifying the rest illness across 6 magnitude scales, that is 0, 1, 2, 3, and 4, 5, 6, and 7, has been described in this proposed study. For training and accessing the model, a dataset of 50,000 wheat leaf photos representing a wide range of diseases. Magnitude it has been like amazing. The suggested developed hybrid CNN DT model with an amazing overall accuracy that we are getting is 93.45%. By carefully analyzing the data set and the crafting of the model. The model's resilience and identify the multiple level of diseases. Magnitude was proved by the performance matrices for each disease's magnitude classes. The proposed hybrid model also outperformed state-of-art models in terms of accuracy as shown by the comparison conducted. The finding provide important new.
You don't have to read the content, that we can also see. You just have to be, specific. I mean, these lines we also can read.
So sure. This is the model, and as we discussed that the accuracy which we got is 93.47%. So
you can come to the proposed architecture section. That's what we are saying.
Yeah. So the literature survey actually according to content the PPT is made. So I need to go through step by step. So agriculture in Pakistan and wheat production, the agriculture sector in Pakistan is the second largest, as we know. I mean, it's a GDP of 17.9%. So the challenges we occurred in wheat disease.
Sorry to interrupt, Anuj. You should always, in the literature survey, give the reference, whatever you are, pointing out.
Okay. Sure.
So this is actually not, I think, this literature survey. You can come to your proposed architecture, whatever you have.
This is the proposed architecture, the collection of and the pre-processing of large data set of wheat rust disease and classification study.
Is this really the architecture?
Yes.
Do you have any flowchart of the architecture or anything? What is this? These are the points.
Basic
like
steps.
The architecture.
Yes.
You
can explain this.
Sorry.
You can explain this.
Yeah. So this is the this is the level one, like weight level, weight that is goes to the level 1. And then this is the levels which we use in the architecture and decision tree. So and using conventional CCNN model. So these are the flow through which the algorithms work. And this is the next all the sessions, all the levels once across. Then that is the planning layer, decision tree, and dense layer. So fully connect. These are the fully connected neural network. So that will get the output of model, then accuracy. This is the hybrid model. So we are using. So the model was trained on the 50,000 images data set, which was carefully labeled as represented various magnitude, as we talked in earlier. So significance, what if we talk about the significance, the hybrid DL model present in this research with a potential improvement in wheat rust disease diagnosis and control, and also this is the production and ensuring food security.
Come to your results.
So the result and discussion. Yes, the result here is a summary of evaluation results and hybrid data model used with the wheat rust disease classification. The data set, as we told earlier, that it's taken around 50,000 images of wheat leaves, and overall accuracy in which we are proposing our model, that is 93.47%. That is the high accuracy demonstrated by the model effectively. So importance and of performance matrix is the multiple classes classification tasks such as detecting magnitude of wheat rust disease, performance and matrices are accessing the model effectiveness and accuracy. So this is the performance matrices: scale 0, scale 1, scale 2, scale 3, as we proposed earlier. 0, 1, 2, 3, 4, 5, and 6. The average, whatever the average of this precision is 93.03%. Recall value is 93.09%, and F1 score is 93%. So the discussion and result is the discussion highlights the significance of hybrid DB model and combine the conventional CCN model. The classification varies magnitude. And the key, if we talk about the key points of the discussion, is effectiveness, disease classification, performance matrix, superior performance, and agriculture significance. If we go into the short, hybrid model demonstrate the effectiveness and characterize levels of rust disease. Performancely, matrices indicate capability at addressing various diseases and magnitude. Superiorness, the evaluation of the hybrid model against state of art. And the variables that we have taken is F1 overall accuracy and F1 score. The superior performance is attributed model ability, leverage strength of CNN and DD.
Fine, Anuj. You can just come to the conclusion.
Okay. The future enhancement, what will be the study aims to categorize we study disease using hybrid model that combine conventional neural network and decision tree. The focus is on 6 different levels as 0, 1, 2, 3, 4, 5, 6, and 7. So the disease magnitude to improve the accuracy, effectiveness, and disease diagnosis. So as we know, the data set is around 50,000 images, which is in high resolution images of wheat leaves. Model performance, as we discussed, that is 93.47% we got. And comparison and other models, hybrid, this is the hybrid model. So
this is just a repetition of what you have already discussed. Anything else you want to discuss?
This is the progress of artificial intelligence, and the future scope is when the more the data set we get from the and we'll get and the more the data the model will be trained and give the more accuracy and the results. These are the references which we are taken in this research paper, and thank you.
First thing is, you have somewhere mentioned 50,000 test images, and somewhere you have mentioned 50,000 total images. So can you just tell me first what is the number of images you have trained on 50,000, and you have tested also on 50,000 only?
Yes, ma'am.
How? So I mean, you have used the same images for training and you have used the same images for testing. So then obviously it is a proper overfitting case.
Yes, yes.
Ma'am, actually this is a hybrid model. So, the model, the data set that is taken from the Kaggle.
That's fine, Anuj. You have mentioned here in your presentation that you have, first thing is you have taken 50,000 images. And second thing, you have used stochastic gradient descent. Stochastic gradient, you know what is stochastic gradient descent method?
Sorry, I can't able to.
You have mentioned in your second point here, the slide which is open right now, stochastic gradient descent was used to optimize the CNN component. Do you know what is stochastic gradient?
I mean, this is the optimizer that is used in the training model.
How it works? Are you aware about this?
I mean,
because
this is
in stochastic.
Okay. Yes, ma'am.
In stochastic, you take, sample by sample, and you have 50,000 image set, data set. And this, in the next slide further, you have mentioned you have tested also on 50,000 image set. I think in the, slides further. Yes. The study collected the data set. You have mentioned somewhere else also. Yeah. So how did you, did you explain this? How do you explain this thing? Is testing and training, this number is same, first thing.
20% is testing. I mean, this is the pre-processing area where 80% is training and 20% is testing.
Okay, so I think you have by mistake written there that testing.
That is actually the data set which I'm telling.
And you have also used data augmentation techniques. So that makes your images more than 50,000 in that case, right?
Mm-hmm. Yes, yes.
So how many data augmentation techniques have you used? Like what all have you used? That probably must have generated more number of images. So you have not mentioned anything about that.
Actually, the PPT will be get too longer. Actually, there is a mention that 15 minutes we have to complete. So the problem in my mind,
it could have been mentioned within one paragraph, one small, means 2 to 3 lines also.
I got it. I'm very
Somewhere
sorry.
You have to mention, you don't mention details, but it should be mentioned somewhere.
Sure, sure.
So actually everything is quite unclear here with all that, data sets you have taken, the scales you have taken, the particular, types of data augmentation you have used, the final results, because once you have implemented all these things, you should have mentioned all the, details about it. What are the particular hyperparameters you have taken? And
maybe I mean,
and what is the specific reason you have used CNN and then decision tree? I mean, why?
Because I think it will get more. Actually, mostly I have worked in that area, CNN and DT area. So
both are used for classification, right? So
yes, yes.
So why have you combined these two? I mean, did you try by simply single CNN or like
it's all about yes, definitely. But what we get the accuracy and the less accuracy, the less precision recalls the values as compared to the what I am getting through this research through. So that's why I'm go through with this and opt this thing.
I must say, Anuj, your work is not at all clear, actually. I mean, it's like not giving you the correct interpretations, and we can't analyze you from your particular values, key, what all is the final result. But so you need to work on that, I think. I think that's all from my side.
Okay, thank you for the recommendations. I hope I'm getting all this recommendation from your side, and hope will make it sure for the next time as well. Thank you.
Okay, I think Madam has suggested everything, so no points from my side. But one suggestion is that whenever you are doing something, just do it properly.
Definitely, sir. Definitely.
Means this
Thank
is
you so
not
much for
good presentation. I'm sorry to say this.
No issue, sir.
Okay.
Thank you, Anuj. Who is ready next? Dr. Shruti Patla, are you ready to present?
Ma'am,
So we have evaluated.
Ma'am, just give me a few minutes.
Yeah. Kindly speak, ma'am. You are audible. Kindly speak. You are a kind of co-author.
Hello.
Yes, you are audible. Please speak up.
Yes, ma'am. Good to go.
Okay, I will call upon paper ID by ID. Please let me know who are all available here. So paper ID 49 have presented Harmajit Singh, and the paper ID 246 Dr. Priyamvada Chandal have presented. 315 Rahul Bandari have presented. 317 Mr. Anuj have presented. Apart from this, other paper IDs 63 Ankita Suryavanshi. Miss Ankita 63, paper ID 63. Paper ID 90 Miss Neeru Bala Bharatwaj. Paper ID 150 Vipashi Kansal. Paper ID 191 Kudrat John Johirao. Paper ID 291 Neha Sarma. Paper ID 315 Miss 328. Paper ID 328.
Yes, ma'am.
Paper ID 328.
Yes, ma'am.
Mehali Das. Yes, ma'am. Are you ready to present, ma'am, now?
Yes, ma'am.
Yes, ma'am. Please.
Okay.
Proceed. Thank you.
Ma'am, is my screen visible?
Yes, it's visible.
Yeah, we can see it.
A very good afternoon to Satyabrata sir and Meghna ma'am. I'm Meghali Das, Assistant Professor, Department of Computer Science and Engineering from Noida Institute of Engineering and Technology. So my paper title is
Good
Comparative.
afternoon, Meghali, but you have to switch on your camera also.
Am I visible?
Yes, now
Yeah,
you
you're
are
visible now.
Okay, thank you.
Go ahead.
So yeah, my paper title is a comparative study of supervised learning algorithms for heart disease prediction. Are the slides changing? Because it's not changing.
No, they are not changing.
Yeah, they are not changing.
I guess it's changing now.
No, it's not.
No.
I mean, we can't see
Slides are
that.
not.
You can unshare it, then again.
Ma'am, can I
share.
present it in?
Now it's okay. Now it's okay.
Yeah, can I present it in this mode? Because the slides are not changing.
Not a problem. You can present.
You can
Okay.
present.
Okay, yeah. So these are the contents. I'll be talking about the abstract of my paper and introduce the introduction and literature survey, and finally the architecture that we have proposed, and then the results and what kind of enhancements and future prospects we have in this research. So basically, this paper is a study on the cardiovascular diseases. Like since we are all aware, like during the COVID period and post-COVID, how the comorbid patients have been affected because of their very stressful lifestyle. So like it is very essential to predict such kind of comorbid patients or such kind of cardiovascular disease at an early stage, so that this mortality rate, which is
Ali,
very
you can
high.
come to your work, like what you have done, like because
Okay,
this is the introduction part. Yeah. What
Yeah.
are the achievements of, and what are your results, and first the proposed
Sure, ma'am.
architecture.
Yeah, so basically in this paper, we have used 3 algorithms, that is random forest, logistic regression, and SVM. We have taken the data set so this is the proposed architecture. We have taken the Framingham Heart Study dataset from Kaggle, and we have done the data pre-processing and feature selection, and then we have used the random forest, SVM, and logistic regression model to see how these models behave in this particular dataset. So this is the data set. I've like summarized the data in a tabular form. So in the data pre-processing stage, we have gone with like we have done the missing values removal and outlier removal. So initially this data set consisted of 4,240 records with
This table is not clear. It's too small to understand.
Yes, you can zoom it, or you could have just break it into 2 parts.
Can you see it now? Is it like
We can see, but it's not clear.
It's not clear. It's not readable. Like we cannot read what is written in that table.
You can zoom it, and then I think. Can you zoom it?
Let me try.
In your rightmost bottom screen, can you see the screen zooming option? Rightmost bottom of your screen, computer screen.
Yeah, it's
yes.
So like these are the attributes, and these are the missing values which are there. So we have basically worked on removing the missing values and the outliers in the data pre-processing stage. So initially the data set consisted of 4,240 records with 15 attributes. And after removal of the missing values, we have 3,658 records left with 15 attributes. Out of these, 2,033 records were female and 1,622 records were male, which has been like so out of these 2,033 records
No, you have to go to that slide.
The table one.
Okay, yes. Please continue.
Yeah. So 2,033 records was female and 1,622 records was male. And the ratio of positive patients and negative patients was 620:111. In this data set, it was primarily found that the female patients had a higher positive, the females were more in the positive heart disease patient. So, and we also plotted the histogram of all the attributes, and we found that the target group was primarily in the data range of 35 to 65 years.
Are you showing histogram right now? Because we cannot see histogram.
No, ma'am, I have not included in the slides, but it's there in the paper. Like, I was not able to put it in the slides. Ma'am, I can otherwise show you the images.
Come to your results and discussion, the next slide.
I think this is a comparative review, na? This is a review paper. You haven't done anything on your own.
No, sir. We have just taken the data set and the algorithms, and we have tried to just study how these algorithms actually behave. Because
No, have you implemented any method?
No.
They have implemented this random forest logistic SVM.
I've used these algorithms on the particular data set. As from the literature review, we found that most of the study was done on KNN and logistic regression. So we just tried to go out of the way.
No,
And
I mean to say, yes. I mean to say that these results and discussions are there in the already published paper, existing paper, na?
No, sir. I have actually taken the data set and I have implemented in my own.
In the beginning, they have mentioned that they have taken this Framingham data set.
Oh, okay.
Yeah. So that from there, the pre-processing is done. So, I mean, have you
by
actually done it?
Sorry, ma'am.
Sir was asking the same thing, the data set.
Yeah.
I mean, have you done the implementation or you have just taken the papers and,
No, we have done the implementation. Yeah, I have
actually,
done
why the confusion
in Python.
arises? Yeah, actually, why there is confusion? Because we can read your paper's title is a comparative study of supervised learning. So the title reveals that this is a review paper, but you have implemented it on your own.
I have done the implementation.
Okay, no issue.
So basically, that was the idea, because most of the research papers, they have worked on KNN and logistic regression. So we just wanted to study how the other popular algorithms like SVM and random forest work, because most of the prediction system use the SVM method. So that was the main idea behind the study. So and what we found was comparatively among all the three algorithms, SVM actually performed better, though the accuracy percentage is not that very high. And so these are the confusion matrices. And
your accuracy is showing correct linear, association. It's like going in a linear manner with the category of the algorithm you have taken. Just perfect. Random, then logistic, and then SVM. So next, can you come to the next slide?
Yeah, I have shown the confusion matrices here, and we have also used F1 recall and precision, but I have not included that in the slides. So those metrics we have also used to check the accuracy, and yeah. So basically,
considering your confusion metrics, can you go back to the slide?
Yes, ma'am.
Yeah, there are a lot of false positive and false negatives.
Right, ma'am. That is where our next stage or the future study is related, because we have taken a traditional data set. Now we are trying to acquire permission from a private hospital so that we can get a real-time data set and actually work on that and see how the pre-processing thing can go on and how we can develop a better system out of it.
So have you shown your number of features, what all you have taken? Because in this slides, you have not shown your data set.
Just mentioning that but the data set had 15 attributes, which was
the tabular part you are saying, right?
Yeah. So this data set had 15 attributes, out of which we have dropped the education feature because we have used a heat map feature from Seaborn, and we found the correlation matrix wasn't showing right. So we dropped the education column, and otherwise we have taken all the other 14 attributes here.
And you have a lot of outliers also in your this current medical history, because I think
we have
this particular
already,
category matters a lot here.
So we have used the box plot and the interquartile method to remove the outliers.
So that means your data set is much reduced after doing the pre-processing because you have removed,
Yes, yes, ma'am.
you have 196 outliers and then
Outliers.
302. How did you handle that?
Ma'am, it was split in the 4:1 ratio, like 80% for training. So,
No, that's fine. I mean, I'm asking, you have just mentioned that you have removed the outliers by using interquartile methods or box plots. And your number of outliers, if I can see here, they're like, the number is quite high. It's 196 outliers are there. And then in this CIS-BP, you have 302 outliers, then DIA PP is 248 outliers. So many outliers are there.
Yes.
So how did you deal with this?
ma'am, like after the pre-processing, we were left with 3,658 records. So
Out of
out of 4,240. Yeah.
So don't you think that these are very small numbers?
Yes, sir. Like it was done in a very short duration, so we had to go with the like predefined data set. But yeah, we are in the process of acquiring a real-time data set. I would really working on it.
Okay, just go to that result and discussion section. Yes. Oh, after that, you have written future enhancement.
Yes, sir.
Okay, then I think, ma'am, it's fine. We can go to the next paper because we have already asked you so many questions. And
No issues, sir. It's perfectly fine. Thank you so much, sir, for giving me this opportunity to present my ideas, and I'll surely keep your all your suggestions in mind, and I'll look forward to making a more better research in this area. Thank you so much.
Thank you, Ms. Nahal. Yes. Next participant is Ms. Neha Sharma, paper ID 317, efficient disease detection in wheat crops. Sorry.
ma'am, it
291,
was okay.
detection and classification of oral cancer. Sorry, sir. Paper ID 291.
291.
Detection and classification of oral cancer. Ms. Neha Sharma, you can start your presentation. Yeah. Paper ID 291, detection and prevention of oral cancer. Ms. Neha Sharma, you can start presenting. Ms. Neha Sharma, can you hear us?
You can call the next candidate, ma'am, if she's not available.
Ma'am,
now reporting.
Okay.
Yes. Now reporting.
Ma'am.
Yes, ma'am.
Yeah, am I audible?
Yes, you are audible. Your screen is very not that much visible, clearly visible.
Ma'am, I'll just set. Is it visible, ma'am, right now?
Yes.
Yes, we can see it.
Okay. Good afternoon, everyone.
Good afternoon.
My study is on the advancements in oral cancer detection and classification using machine learning.
Neha, you are not visible.
Okay,
Yes, you can switch on your camera.
You were visible earlier. I think, yeah, right now you are not visible.
Okay, I'll just do that. Ma'am, am I visible?
Yes, yes, you are.
Yes, now we can see you.
Okay.
Please go ahead.
I'll just share the contents. Can I skip the contents part?
Yeah, you can skip and you can come to your work and your proposed methodology
Okay.
and the
Okay.
results.
Okay, fine. I'll start with the introduction part that talks about the global prevalence of oral
No,
cancer.
it is not required. You can come to the proposed work section and then you can go to the result and discussion section.
Okay. I'll just come to this table, which actually says oral cancer, the incidence rate and the mortality rate across the world. And if we see this figure, this is the deaths worldwide due to oral cancer, which is 177,757. This data is taken from the WHO database. Right. So some literature review on oral cancer diagnosis using machine learning is given here, which actually states the global health concern, the machine learning integration with oral cancer diagnosis, and some studies of various researchers. It also states algorithm diversity and algorithm performance, which exhibits various levels of accuracy, precision, recall, overall performance, etc. Also, there is scope for some future research in the same area, which actually can lead to lesser number of deaths due to oral cancer.
So you have done the study thing, or like you have done
table.
some implementation also?
Right. I'll just let you know, ma'am. In this table, in this particular table, I've done a comparative analysis of machine learning models, which actually give different models and their different value sets. For example, we have model 1, logistic regression. In this, AUC value is given as 0.858, which actually means 85.8%. Similarly, there are various values for CA, F1, precision, recall, and MCC. As a summary, I would like to say that in this table, from this table, we can infer that SVM model, the last model here, is actually the best model amongst all, just because it gives the highest values in all of the columns. If we see AUC under SVM, it gives 0.897, which is highest among all. Similarly, all values for SVM are the highest. So this is regarded as the best.
What is this CA and MCC?
Sorry, ma'am.
CA and MCC.
Ma'am, there are various value sets.
What do you mean by this CA? I mean, can you explain this CA and MCC?
Ma'am, just give me a second. I'll just go back to the slide.
No, you have used one abbreviation, and whenever first time you are using some abbreviation, you have to just expand it, and then you have to write that within a parenthesis. This is the norm. This is the generalized rule. And otherwise, if you are using certain abbreviations in a table, then you should just put a star marks below the table, and you can just expand. Otherwise, how the readers will know?
I get it. That's basically some accuracy value right there. And MCC
That's
is
fine.
also...
I mean, what I'm asking is like
I got it. Okay, ma'am, I'll do that the next time. Ma'am, here are some pictorial representations.
What are the formula? Something you have to mention, no?
Okay, if you have not mentioned, even if you have mentioned, are you aware what are these things, CA and MCC?
Yes, ma'am. These are the variables against which these models are, analyzed. I'll just keep that a point to mention the full forms the next time.
Okay. Continue, please.
Right. Ma'am, these are the same models which I've used earlier. These models, logistics regression, naive Bayes, neural networks, random forest, and SVM. These are now pictorially represented here, keeping the same values as it is. These are the pictures for cancerous and non-cancerous cells, showing cancer and non-cancer in various humans. This is the logistic regression. These one are the naive Bayes model, the neural networks, This is twice. Random forest. And here the SVM model.
And what is your result analysis? Okay, first thing is, why did you prefer, your data set is image kind, right? They are the images.
Right, ma'am, right. Right.
So, I mean, is there any specific reason that you have used machine learning traditional methods for this images when you have many better models are already available, which specifically are used for, images?
Mm-hmm. Ma'am, actually, I've used a combination of pictures as well as data for my research. And the reason for using machine learning is that it is an area where the research can be done. It has,
This is
more
after
scope.
you have used the structured data, or like this is the result after the one you have shown here. Is it using the data set as images or the rest of the attributes related to that images?
Ma'am, I didn't get you.
That?
We have used the Kaggle's model.
Kaggle's model, where the data set, what is the type of the data set you have taken? I mean, is it images or the information related to those images, which is giving you these results?
Images, ma'am.
So that's
How
what I've
many
asked.
images are there?
I'll just tell you the Kaggle's model in which I've divided actually, right. I've categorized oral tissue samples as into two parts, category 1 and category 2, which is actually class 1 is cancerous and class 2 is non-cancerous. But the basis of my study is pictorial data, the images part. These.
So you have not used CNN here?
No, ma'am.
How did you take the features of these images? Did you do some feature extraction method? Did you use that?
Ma'am, I studied various symptoms of cancer and non-cancer causing, the symptoms which show. So these are the pictures.
That's fine. How can you say that the fourth picture is of a cancer patient and the first one is of non-cancerous?
Okay, ma'am. I actually did comparative analysis of all of these. That is how
you did comparative analysis. That is fine, but some feature extraction algorithm must be implemented in this case. Nah. Otherwise, how can you just by seeing? How can you just identify all these things?
You have implemented these models, right?
Right.
And in these models, you must have given input, some input as data. So what is the type of the data set you have taken? On what basis you have conclude, like you have given this, classification that it is cancerous or not cancerous? What is the kind of the...
Ma'am, after taking all the inputs from Kaggle's model, that is the basis of my research. And from there, I've actually, taken these pictures and used them as reference for my own picture of my own study.
Yeah, the simple question is, with these images and this traditional machine learning algorithm you have used, how did you use the different features? When we are giving input for any classification model, you generally give features, right? So what are the features in your case? From these images,
are you talking about
all the images you have taken for all the machine learning models? How did you use the different number of features, different types of features? I mean, what were your features for these images? Because once you are using machine learning, you have to do some feature extraction. Otherwise, you can directly use deep learning models where the feature extraction is done automatically. So,
right, I get your question, ma'am, now, but actually, I'll have to, just go through it once again because I'm not ready with
So who
right
implemented
now.
this work?
So my associate, Amit Kumar, also, contributed a lot in this paper.
So it's not good to present without knowing the method in detail.
Right, right.
It is a wasting of time of yours as well as ours.
No, not actually, sir. Just the image part. I'll, just
okay, these are the result. Okay, what is your analysis?
So my analysis is the same, that SVM model which we actually used, that can be,
No, show us
That
the analysis part.
after a comparative analysis of all the models, I could infer that SVM model is the best among all of these, and it can be used for further future research in this area.
That's it.
Right, sir.
Okay.
Okay, Neha.
Thank you.
Okay, we can understand that you don't have any other result analysis to show. So in that case, we can go to the next presenter.
Yes, sir. So next presenter is Ms. Ankita Suryavanshi.
What's the paper ID, ma'am?
Actually, two IDs are available, ma'am. 63 and 468. Second one and last one.
Okay.
But right now, she has to let us know which
Yes, ma'am, I'm
paper
available.
ID she is about
Just
to.
give me a second.
Yes.
I'm ready to
yeah.
talk.
Okay, nice.
So while presenting, tell us the paper ID also, Ms. Ankita. There are two paper IDs associated with your name. Ms. Ankita, what is happening? Will you let us know? We are waiting. Session chairs are waiting.
Ma'am, please wait for a while. I'm traveling from my college to my respective room. That is why I'm not able to connect properly.
In that case, we can ask the next one to present. Who is next?
Yes, sir. Actually, participants are not available. Some of the participants. Actually, paper ID 63, paper ID 90.
63 is Ankita, right?
63 is Ankita. 90, 150, 191. They have not responded.
Present?
They have not responded and they are not available. Yes, ma'am.
Okay.
90, 150, and 191.
Yes, consecutive numbers.
Okay.
Identify the brain stroke, authentication of voter.
And what about 468?
468 is also the same girl, Ms. Ankita.
Okay.
Yes,
okay, so she is the only one left. Okay.
Yes, ma'am. Yes, ma'am. Meanwhile, if possible, can you give your feedback, valuable feedback and suggestions for improvement to other participants so that Ankita, are you ready?
Hello?
Because they are waiting, session chats are waiting. Paper ID 150, are you ready?
Yes, ma'am.
Yes, ma'am. Please proceed. Ms. Vipashi Kansal, authentication of voter using convolutional neural network and blockchain. Am I right?
Yes, ma'am. I am one of the co-authors.
Yes,
I am
please proceed.
from Hill University.
Yes, please proceed, ma'am. Sorry.
Shruti, can you just put your camera on?
Ma'am, I would like to have a small favor from you. Actually, I am traveling, so because of the bandwidth issue, I can just share. Otherwise, there are some glitches in the voice.
Okay, no, okay, fine. Then you can show your presentation.
Yes, ma'am. Thankful to you.
Paper ID 150, ma'am. Paper ID 150.
Yes, paper ID 150. Roti.
Authentication of voter.
Yes, ma'am, noted.
Yes, sir. Yes, sir.
Which one?
Paper ID 150.
Okay.
Authentication of voter. Yes, ma'am.
Okay. You can start, Shruti.
Yes, ma'am. Just few minutes. Ma'am, is the screen visible?
Screen is visible.
Yes,
Presenting
yes.
via your
You're
mobile phone.
using mobile for the same, right?
Mobile.
Yes, ma'am. Because
Okay,
I'm
it's visible. You can just zoom it and then show.
So I'm just to begin with the introduction or directly jump to the proposed methodology part?
No, you can start with your methodology and then what is your contribution and the results and analysis.
Ma'am, actually I'm made to present this presentation at the very last moment because of the unavailability of the other authors due to some medical issues. And I am particularly concerned with the literature survey part in this research paper.
Okay.
So here beginning with the proposed architecture, the bullet points are data collection, face recognition, face projection, implement open face, reflect loss function, testing and evaluation, biometric authentication. To have a brief overview, I would begin with some explanation of all these. In this section, we have basically outlined the suggested methodology for voter
You can
authentication.
go to the next slide.
Show your diagram.
Yes,
So the next slide is all concerned about the results in which the figure 1 shows LBP conversion to binary. And here the LBPH algorithm performs the face recognition part particularly. This is by comparing the histograms of the test and training images after future extraction.
What is the full form of LBP?
Sir, LBP is local binary pattern histogram face recognition system.
Okay. And histogram you have analyzed?
Yes, sir. The analyzation part have been actually done by some other authors. I am just concerned with the literature survey, and I have been overviewed about this entire part just some moment before.
But you must have gone through your paper, right? And you must
Yes,
have
yes,
at least because you were the part of it. So
yes, ma'am. Yes,
did
ma'am.
you did you do some study about that, about your own paper, and then if you can show us that also.
Ma'am, here in the slides, we have just outlined the overall work.
That's what we are asking, what overall work is done and how the implementation process is done. and then what were the results and how were they compared with the existing work?
Yes, you
ma'am.
can explain these 4 points. Then it's done.
Did you get it?
Yes, ma'am. Just few minutes.
Okay, that's all you have to show? These results, because these are not actually results. This is like just you, one of the snapshot you have shown.
Yes, yes. Okay, Shruti, what do you mean by authentication?
The authentication would be the specification of the overall that we have done with the images.
Pardon? Please say it clearly. What do you mean by authentication?
So here authentication would the process of showing something that means actually the face is true or means the original person is there or not in case of this paper.
Now tell me how you have authenticated one person. Suppose that I want to vote. Okay. Now, how would you authenticate me that I am actually the voter?
So
And
this
which
we have
machine
done.
learning technique you have implemented?
So we have implemented blockchain technology and CNNs.
Okay. Now, how did you authenticate that
So
it's actually
using the deep learning methods for picture categorization.
picture categorization? Okay. What
For
is
that
that
you have
method?
used CNN.
Pardon, ma'am?
For that, have you used CNN?
Yes, ma'am. We have made the use of CNN also here.
Also here. And what else? For blockchain, what is the purpose of using blockchain technology? Okay, you mentioned that you did that literature survey part. What all was your conclusion after the literature survey? Can you just highlight that?
Ma'am,
Yes,
the
at least that you
conclusion,
can say.
ma'am, for the conclusion, I would say that here the long-standing issue of voting practices, which is actually followed, can be replaced by using the CNN networks, and our methodology ensures that only the authorized person or the authorized concerned voter can participate in this electoral process, while thus maintaining the confidentiality and further high level of security in this process.
Okay. How many paper you have read for this paper?
So I have on my part gone through 10 papers.
Okay. So by reading 10 papers, you have written one paper.
So because this is just the beginning what I've entered through.
10 papers are good enough if you have actually studied them. So, I mean, what all but the state-of-art methods used on those 10 papers?
Yes, that you can tell.
Would you please elaborate this?
No, you have performed the literature survey, no? So then you must have known that what are the methods that all those 10 papers have presented.
So the methods were mainly concerned with the face recognition part actually, and so
For
the CM,
authentication, what did they do? For authentication, what method they have used? Any
they have
asymmetric cryptography techniques or any other techniques, any hash value generation or any digital signature scheme, what they have used?
so I have gone through the papers which have analyzed the digital signatures also using the image processing one, OpenCV implementations.
Now, in this case of blockchain-based technology, have you computed any hash values or how key exchanges were done? Can you tell us?
So when talking about the blockchain part,
Yes, I am just focusing on the authentication part.
so here we have used for authentication the biometric information of the concerned voter or the the data which the blockchain would further process.
Anyway, I couldn't get it. Okay, can you tell us that what is the difference between face recognition and face projection? That means what you want to, means what you have done in face recognition and in face projection, what you have done.
The face recognition, describing it particularly, would be like that there are several images of several face images we are having, and we are analyzing a particular image based on its feature that can be termed as face recognition.
Okay, and face projection?
So for face projection, I would say that processing a particular face image from various angles.
From various angles. Okay. But you cannot show us any further thing about this, no?
Yes, sir. Sorry for that.
Okay, then I think, ma'am, we can go to the next paper. I think because it is very unclear about from this presentation. We cannot get any idea.
Yes.
So I would take your feedback as a good lesson.
Yes, sir.
So whenever you are
Thank you,
presenting
Ms. Butler.
okay. Okay, now you can go to I think Ankita.
Ankita is the only one left, right?
Yes, ma'am. Yes, ma'am.
Okay.
Give the presentation.
Ankita. Miss Ankita is.
Good evening, ma'am.
Miss Ankita. Yes.
Good evening, ma'am.
Mr. Vinay, you are representing Ankita.
Yeah. Actually, I am a co-author of this paper.
Yes. I saw your detail. Which paper you are now about to represent? 468 paper ID or 63?
Yeah, 63.
63. Okay.
Yeah. Can I share the screen?
What about Ankita? What about Ankita?
Actually, ma'am, today is Karva Chauth, so she's busy there. So that's why I'm presenting my this paper.
Okay, Mr. Vinay, please proceed. From deduction to severity estimation, a unified CNN SVM strategy for taro leaf blight disease. Am I right?
Yes. The screen is visible.
Please proceed.
Yes, it's visible.
Yes, it's visible. You can see it.
Okay. Coming
You
to
can
the
put
title.
your camera on.
Yes.
Vinay.
Sure. You can't see. Actually, I'm not aware about this.
Okay, you can continue.
Please wait. The paper title is From Detection of Severity Estimation, Unified SVM Strategy for Taro Leaf Blight Disease. Actually, we have discussed the severity level of in this paper using the CNN and SVM approach. Coming to the content section, we cover the abstract.
Come to your work, like what methodologies you have done. If you have done some literature survey summarization, you can show that, and then come to the proposed architecture and then results.
Okay. Actually, first of all, we take the data set from the primary as well as secondary resources. After that, feature extraction using CNN model. After that, the classification using SVM. For the SVM, we have connected the fully connected layer in this. After that, we can predict the results. It is clear in this diagram. Here is the input image. In this, we have taken the dataset and augmentation. After that, image pre-processing will be there. After that, feature extraction using CNN. And for that, classification using SVM. We have connected 3 convolution layer and 1 max pooling layer. And in max pooling layer, we are connected the flattering layer and 1 fully connected layer. In SVM layer, we are using the regularizer. After that, we are predicting the DL1, DL2, DL3, DL4, and DL5. These are mainly the results. Basically, it is shown in this figure. We are taken five classes like A, B, C, and D and E. Here we are taken the number of images we are taken here. After that, in bottom side we are taken precision values, and on the left hand side we are taken the actual values. This is the basically the confusion matrix. For that, the classes intensity, basically we are predicting the class A. The leaf have the disease level of 1 to 20% is under the class A. In class B, 20 to 40%. In class 3, 40 to 60%. And class D, 60 to 80%. And class E, 80 to 100%. We can also calculate the macro average as well as weighted average in this. And the name of the table is dimension of the layer. And the conclusion of this paper is the use of CNN convolution and SVM in the conjunction to identify the leaf blint disease in the taro plant. That was conclusion of the study article. The model showed high accuracy in the categorizing various disease intensity levels, spanning for moderate to severe. After through experimental and review, the model capacity to explore well undefined example was ensured by use of extraction of complex diseases. Feature from the photos of taro leaves was made possible by the structure of the categorizing model, which include 3 convolution layer where I have to follow the 1 max pooling layer. The last layer introduce of SVM produced a dependable classification mechanism, enabling accurate and trustworthy disease prediction. Precision farming will greatly benefit from successful use of approach for leaf blint. Yeah, these are the references which we are using in this. And thank you. Any question regarding this you can ask.
Okay, so you have used first this SVM and then this
Yes.
decision and then this convolution neural network, right?
Yes.
So what is first thing is you have not mentioned anywhere what is the data source here?
Ma'am, data source, we have taken data source from Kaggle as well as secondary source. Actually, we have tie-up our university with some health institutes and laboratories. So we can get data set from there. After that, we are taken in this, we are taken 189.
So you have done the training from the existing publicly available data set
No, ma'am. We have taken our own data set as well as we are taken from online sources also.
So what is the number of images you have taken?
Ma'am, in total number of images?
Of course, yeah. For training, how many images have you taken?
Ma'am, actually it's around 700 to 800 images.
700 to 800 images. Yeah, and what is the, I mean, it must be a labeled thing, right? So how many were labeled as diseased or not diseased?
No, we are taken only diseased images. Actually, we are taken the leaf. Hello?
Yes.
Yeah, we can taken a leaf who has actually suffering from disease, right? After that, we can predict that the disease has how much intensity level, 1 to 20%, 20 to 40%, 40 to 60%, 60 to 80%, or 80 to 100%. We can calculate in this table precision, recall, advanced score, support, and accuracy.
Okay, so that means there must be the labeled classes available already in your data set. That's why that is how you can do it, right?
Yes.
So you must be having these 5 categories already in your labels?
Yes, ma'am.
Okay. Yes. So, I mean, you have taken first this machine learning approach where you have done some feature extraction, and then finally, after the classification you are using those as inputs for your convolution. And can you just explain the kind of the values you are giving?
Ma'am, first of all, we are taken the all over data set. After that, image pre-processing will be there. After that, feature extraction. After that, we are taken 3 convolution layer in this. And
so you are using feature extraction within using CNN, and then you are using classification with SVM, and then again you are using convolution for this. What is the complexity of your model?
Yes, it is a repetition of the CNN.
Actually,
it will be very complex.
Yes, sir. Actually, in this diagram, we are showing that we are taken the data set after that image pre-processing, then feature extraction. This is the we are only the CNN part is will be involved in the convolution layer, where we have using the feature extraction only using the CNN. After that, we are extracting the feature only with the help of SVM regularizers.
Actually, your diagram is not giving the clear picture because
Yes, ma'am.
here
Actually, maybe she's doing some mistake in this.
Yes. So in the paper itself, you have presented this diagram.
Yes.
This diagram is there in the paper. So it must be corrected, na?
No, sir. Actually, this paper is not in the paper. Actually, it's only in the presentation only.
So in the paper, have you shown some particular set of methods or some diagram? Have you shown in the paper?
Yeah, ma'am. Actually, we are taken this only convolution. We are using three convolution layer and max pooling layer and fully connected layer. After that, the output is showing. The blue part is not showing in this paper. In the paper, actually, this is wrong. Yes, you are right, ma'am.
Okay, so you need to correct it because it's giving the wrong interpretation altogether.
So sorry for this, ma'am. Sorry.
Okay, that's all.
Can I go for the next?
Yes, I think, sir, you want to ask something?
No, ma'am, it's okay. It's fine. Thank you.
Thank you.
Okay, Vinay, you can continue with the next one then.
Yes. The screen is visible right now?
No, we can see the old paper. You will present the next paper.
Sir, this is not showing, sir.
Paper
It's showing the old one only.
No. We can see paper ID 63.
Wait a minute, sir.
So Mr. Vinay, you are about to present for 468 also.
Yes.
So 468, ma'am. Advanced ABS disease recognition in lemon. Multi-level approach using CNN and random.
Okay, ma'am. Like the last one, right? Yeah.
Yeah, last one. Yes. Sir, last one, sir. 458.
Yes. 458. 468.
How it's showing, sir?
Yes, we can see it now.
Okay. The paper title is Advanced ABS Disease Recognition in Lemon, a multi-level approach using CNN and random forest sample.
This ABS?
Yes.
What is ABS?
ABS disease.
There must be some full form, like you must mention in your paper because.
Sure.
Okay.
Until and unless it is a very well-known abbreviation, you cannot use. Like CNN is a well-known abbreviation. DNA is a well-known abbreviation. You can use that.
Okay,
but
sir.
ABS is not that much well-known. So you have to just, I think, reframe according to us.
Sure,
What do you think, ma'am?
Yes, sir.
Sir, in the final paper submission, we can correct this. The full
Yes,
form
you
of
should, I think.
ABS.
We'll do the necessary.
Coming to the content part, basically we are conduct the abstract introduction literature survey.
Now you can come to your methodology as you did for the previous paper. So same way you can just show.
So again, you have made the same mistake in the diagram.
Yes.
That
Yes.
Okay. You just explain. You just present it. You can explain. You can present your work.
But
Yes.
actually, you told me that there is a wrong figure. We can change our figure.
You have to change, I think, Vinay, because
Yeah.
it's giving
Sure.
the wrong idea about your own work.
Sure. So actually, in this only the data collection will be there. These are in blue part which we are taken here. We have to change this, right?
Right.
Okay. So in this also we are taken 3 convolution layer
And I
and
think
1.
you should also mention here because in all your diagrams, when you are defining convolution, there is no mention of the size of the filters, number of the filters,
Yeah,
and
right.
image size.
Okay.
And here you are mentioning that you are using pooling just at the end after 3 convolutions. So in between, you are not using any pooling thing. So
No,
is it
no,
so?
no. Actually, we are using 3 convolutional layer. First of all, after that we are using pooling layer because this is effect on the accuracy. That's why we are using this.
Which pooling method are you using here?
Third.
Hmm?
I don't know, ma'am. Actually, our
Who has
guide.
implemented this, Vinay?
Actually, Ankita is implementing.
Ankita is there, I think. Okay,
Ankita,
fine. So
yes.
she you can't comment on this.
No.
I think okay,
This is
fine.
not actually the right way of presenting something. If you are presenting, then you have to have the idea of everything.
Clear idea
what is
about it.
written in their presentation.
Yes, sir.
Because this is official, na. This is not any informal thing. This is an official presentation which is being recorded and is going to be published in some publisher.
Yes, sir. You are right, but unfortunately, she is not present, so that's why I'm presenting.
But I think you're also one of the co-author, right?
Yes.
So you must have studied your own paper.
I can't see the presentation.
But in the paper, you must have done it. It is not in the presentation, but you must be aware that what pooling methodology, which type of pooling you have used, what is the size of the image. I mean, you
must be written in
Yeah,
the
size of the image is 256 into 256.
okay, and rest all the details also must be written in your paper. If they are not written, then you have to include all these details.
Sure, ma'am. The same we are taken 5 classes in this also. So in the bottom side we are taken the precision values. On the left hand side we are taken the actual values. This is the confusion matrix we are taken. This is the conclusion that the study has led to include the powerful methodology that integrates the convolution neural network and random forest can be developed and deployed for the accurate detection of disease in lemons. Key CNN parameters including kernel size, learning rates, and activation function were
Rigorously tuned.
Guarantee optimal feature extraction and model demonstrating the efficiency for the method. The author also
So have you mentioned the same conclusion in your paper also?
No, ma'am. Conclusion is different, ma'am.
This is conclusion for your paper, right? Which you are showing here. Because here also again, you are mentioning random forest and CNN. And again, you are mentioning the parameters, nothing about the details. I mean,
Ma'am, in conclusion section, we have conclude in this paper, we have conclude that we have taken the 5 classes and we are identification of diseases phases, right? So here we have represent in conclusion section, and we are taken this paragraph also. So this is the different thing, and we calculate the precision for every class and recall for every class. F1 score support accuracy. For class 1, accuracy is 96%. For class 2, class B.
That's okay. That's okay. Fine. We can see that. And what is the macro average and micro average? Are you clear about this?
Yeah. Macro average, weighted average, and micro average. We also conclude that also.
What are these? Macro, micro, and weighted?
I think he doesn't know this. And now you can tell us the full form of ABS disease.
Sir, I don't know the full form of ABS because
it must be
What was
written
your
somewhere.
contribution?
Yes,
Vinay,
ma'am. Actually,
what was your contribution in this paper? Because you don't know anything about this paper.
Yes, ma'am.
So you are one of the authors, huh? Second number.
Yes.
So this is very pathetic situation. At least being a second author, you should have a sound knowledge about what is going on in this paper. You should have coordinated with them.
Yes.
You had the schedule beforehand. At least 7 days before, you knew that this is going to be scheduled on 1st of November from this time to this time.
Actually, Ankita sent this PPT recently that she has on any another plan. So
No,
that's
these
why
are
I'm
the
presenting this
excuses.
paper. No, sir. This is true, sir.
Okay, Vinay. Fine.
Okay. Thank you.
Thank you, Mr. Vinay.
Thank
Now we came to the end of the session. We thank the session chairs for their sincere support. And throughout the session, they gave valuable suggestions. I request the session chairs to give your valuable suggestions to the researchers so that they can. I also attended the session fully, and I noticed the things here. Definitely, I will inform this to the session chair and co-chair also. But beforehand, being the budding researchers, you can give them your valuable insights. What is actually researches? Those sort of suggestions you can give them, sir. That would be a very great support for them, I guess. Sir. Madam, please.
Ma'am, actually, yes, there's a lot to be learned by these researchers. These are the budding researchers, we understand. But yes, there are some things which are like the norms, like say, for example, they are using the term proposed architecture, where we cannot, like they are not actually clear about the meaning of this proposed architecture. And when they are presenting, I mean, I think it's very important. First thing is to read the paper, to go through the paper. And whatever, even if they are the co-authors, there should be a proper coordination among these authors, and they should be clear first about their own research. So that was missing here. Maybe there was lack of coordination, and they were like more concerned about their part of the contribution. So that's one thing. Another thing is, yes, the way they are presenting, I think sir has already pointed out many a times where are they lacking. So they must be aware by now what are the problems. So I mean, for each presentation, sir has already mentioned what are the flaws. So I think that is the part of the learning process, and they need to work on these things.
So participants, kindly take the suggestions of the session chairs into your serious consideration, and the research is very great passion. Okay. So we expect a lot of things from you, and whatever conference you are going to present, whatever the technical article you are going to present, please give your valuable insights, deeply involve in research, and then produce your outputs. But anyhow, thanks from our end. And now over to Dr. Sir Satyabrata Roy, sir. Sir, please, sir. Kindly suggest.
Thank you, ma'am, and thank you, Dr. Meghna Sharma, ma'am, for providing this opportunity, and to the presenters, to the budding researchers. I'd say that yes, there are two aspects, as ma'am has mentioned, that there is first technical aspect. So whatever techniques you are using, you must have a sound knowledge of everything. That why you are using this. This is not because everybody is using a particular technique and you are again using this you are doing simply mix and match, permutation and combination. Don't do that. Okay, you just ask yourself, you just try to get the answer that why we are applying technique 1 first, then what is the output of technique 1, and you are applying then technique 2 on the result set of technique 1. So these technical aspects you must have to be very clear. Now for this presentation point of view, for referencing point of view, I have already mentioned that there are means presenting and writing paper are two different sets. Whenever you are presenting something, then you have to just refer. If you want to refer something, then you can use footnotes or you can give links just immediately below the slide. And if you are using some numeric value, then you can do that in your paper, where you have means in the end of the paper in the conventional way. Okay, but in the presentation, you always try to just cite the link or like that. Okay. Now, second thing that yes, using abbreviations, using tabular formats, using high quality images are very much required. And whatever is there in the PPT, you must have a sound knowledge of that. Even if you didn't do that on your own, but you should have discussed with your co-authors, and then you should present, because these are the things where means these are the official things, these are the things where all the other countries, all the other participants will watch rigorously. I will take some feedback. Then if you are doing like this, then what they would learn, that aspect we have to just think. Means we are not discouraging you, just we are just telling that you should do these things. Now all the other things we have mentioned while presentations, and that's all from my side. Thank you.
Thank you so much, the session chairs, for giving your valuable time, valuable suggestions to the participants. And Amity, on behalf of the Amity University Tashkent and the Department of Information Technology and Engineering, we all are much gratitude for your service today. And thanks a lot, sir, for being with us
It's our pleasure.
prolonged time, because the session is expected. Thank you, ma'am. This session is expected to be ending by 5:30. I guess now it's 6:15 in India. But thanks a lot. Thanks a lot,
It's
professor.
okay.
Yeah.
Okay. Bye.
And as a gratitude of our love and affection, we will have a touching with you through mail. We will converse with you later. Thanks a lot.
Okay.
And
Nice.
now, participants, please stay back. I will share the feedback form of this conference session link.
Okay, thank you.
You
Bye,
can fill the
everybody.
feedback.
Okay,
Thank you. Thank you,
thanks.
sir.
Thank you so much.
Thank you,
Okay, sir.
Meg.
Okay,
Thank you,
ma'am.
Dr. Meghna, ma'am.